Hey, welcome to a new video on the Cell Doctor channel. Today is about the Mega CNC, the software I developed for controlling the Megacell chargers. I've been working for the past days on some new features that a lot of people requested. So let's see what's changed since the last video. I've replaced the placeholders I've had on the page. So these are the total cells that I've been testing on the development machine. I'm running it on a Windows machine, but it's quite complicated to get it down. I'm running it on the Windows because it's easier to develop and submit the changes. But as you know, the deployment process works best on Ubuntu. And the image for the Raspberry Pi, that by the way I will be updating in the following days for those that did not get it or they have the link and they want to maybe burn it again. But if you already have cells in your database, I would recommend going through the update procedure that's described on the Git page. So you will have to log into your Raspberry Pi or the Ubuntu machine where you're running it. You can use SSH. The default username and password for the Raspberry Pi image is MCC admin. That's the username, and MCC is the best. Like so, it's the password. So this right here is the password. You can change it if you want to, but Megacell Charger is the best anyway. So this is what you have to do. Go to Mega CNC, do a git pull, sudo docker compose down. You'll have to rebuild, and you also have to make the migrations because I've done some changes on the database as well. Right, so let's get into the changes on the database. You will see a new entry right here. It's called database, and this by default loads all the cells. I still have to test to see how it performs when you have like 2,000 or 3,000 cells. If it takes too much time to load, I might have to break it into multiple requests, but for now it's okay. So right here you can filter the cells depending on the project that you want to get data for. Right, so this is what you'll see. These are the tested cells. You see some of the cells are in the database before I implemented some functionalities, but like the latest ones will have all the data that we record. So when you click on the plus sign, alright, so for example we have this one which has the capacity of 2960 milliamp hours, an ESR or 0.08 ohms. You will see the number of cycles that was set for this cell. Available, yes, it means that it's not used yet in any pack, so it can be used in battery creation. So you'll have the temperature before test. That's to give you a baseline to know the environmental temperature when you tested this. Then you get the average temperature charging and the average temperature discharging. Max temperature while charging and also max temperature while discharging. That's about the database. Right now you can also manually add cells. You select the project where you want to add the cell, you set the type, device type. Maybe you're using Opus or something else and you want to add the cells in the database. You'll see like setting a voltage like 4.2, capacity ESR 005. You can also record AC ESR if you want to. I still have to add that into the other cells, but I'm thinking about a workflow to do the measurement for the AC ESR. Minimum voltage 2.8, store voltage 3.7, max voltage to 24, testing current 1000, constant current, and you click on add cell. You'll see that I kept these settings. If you want to add more cells, you can just change the capacity and the cells will be added to the database. And to see the cells that we just added, let's refresh the page. So these are the cells that I just added, 2.8. You'll see that there's no graph on them. There's no temperature data. It's just the default data that we added, 3500. And if you select them and you click on print, so it printed me these QR code labels. Let me switch to webcam, maybe you see it better. So this is for those that are not familiar with the purpose of this software or the Megacell Charger. So this is the main scope. I developed the software and also the hardware for testing cells, because I will be getting to the batteries page. This is the database. This is great. So this is great. You can see the data. You see all the cells that have been tested, and that's great. But when it comes to using the cells, this new page that I'm showing you right here, this is the main reason for using the Megacell Charger and QR coded labels. So right here I have created 2 batteries. It's not fully functional yet. You cannot delete the packs. You can just create. So add a new battery 3. Let's say we have 8 series with 2 in parallel. We add the battery. It created a new battery for us, so this is it, battery number 3. And when we click the plus sign, you will see some things. Like I said, still working on it, but I just got the functionality done and it's usable. I used it, and I think you'll find it very useful. So the first thing you have to do is to select the project. You can select all. That will give you access to all the cells that are in your database. And the beautiful part is right here. You can do the following. You can move the cells from the database if you want to, but the easiest way I found to use this, and the reason I designed it this way, is to be able to scan the cells. So you take the cells, let's say you want to build this pack, it's 16 cells in total, and maybe you have 1,000 cells in a database. You just go to the box where you store the cells, grab 20 or 30 cells, how many you want, and then you start scanning them. I'm using a QR code scanner, and when you scan it, it will automatically pull the cell from the database and move it to the transfer cells. And that's great, because the next thing you do after you scan the cells, let me show you. Let me scan 16 cells really fast. Alright, so we have 16 cells added to the transfer cell table. And now the magic thing is when you click the assign button. Right. So you see that it assigned the cells. It does some computation to find the best combination to have a balanced pack. So you see it's just 30 milliamps difference between the highest and the lowest that I see. Yeah, 25 or something like this. Yeah, 30. Yeah, 30. This one is about 30 milliamps. That's very low. And the nice thing is the following. You scan the cell again, and it will highlight you and tell you in which string you must place that cell. And that's very powerful, guys, because the first time we build a pack, we spend like half a day or more to arrange cells, place them on the floor, and begin reading the labels to the writing on the cells, because we were first using Opus and just write it on the cell, the capacity, and it was a nightmare to match this. And this is a small pack, this is 8 by 2, but imagine if you are doing like a 16S and you have 16 strings, and if you want to do 4 parallel or more. I remember we had like 100 and something cells to sort, and we spent a lot of time on it. But if you're building a larger pack, that will go even more insane. So next one, go to slot 6. Next, this one was not used. Okay, slot 5. Slot 5, and I think you got the idea. For me, it's a huge time saver having this right here. And when you save the pack, all the cells have been saved, and right now they are marked in the database as not available because they are assigned to the pack we just built. So if you're opening this again, you will see that the cells are assigned. If you are going to reset the cells and save the pack again, those cells will be back on the available stage, and you can reuse in a different pack if you change your mind or for some reason you want to do that. I still have to figure out what will happen if you delete the pack. Will the cells get deleted as well? Probably they just stay in the database and marked as not available. And you also have another way if you don't want to scan it like I did it, and let's say you just created a project just for that pack. You have a 200 cells pack, you create the project, you select the projects right here, and you want to filter which cells you want to add from the pack. So you auto select them, it will give you 52 cells. And when we assign them, you see it updated it automatically. And if we begin scanning the cells, you see it found it on the 10th row right here. So I just grabbed it random, but because there are so many in this pack, it just found it and say okay, it's on string 5. It doesn't matter that it's the 4th cell or the first one, you just put it on the same string. That's what it's important, to have a balanced strings, because if you just grab them randomly, you might end up putting the best cells in one string, and then you have another string with the worst cells, and that will unbalance the pack and not charge evenly. And after a few charges and discharges, the pack will go unbalanced, and you will not be using the entire capacity of that pack. So having the software calculate this for you, I think is very useful and a time saver. Let me know in the comments what do you think about this feature. What other things you want to see in this table right here, like deviation numbers. So that will tell you what's the difference between each string, like the lowest and the highest. And also if you want to change some of these cells, you can swap it. So you go and swap. Not sure how this will perform, if it will if you have this saved already. I still need to do that to allocate back. So if you're saving it and then you change your mind, you add other cells in the pack, I need to allocate the other cells back. But for now, use it simple. Don't mess with it because it's not made at the moment to be messed with it. I try to get the basic functionality done because programming takes a lot of time, and you need to think all these scenarios, what will happen if this and that, and test for those scenarios. But for now, if you're using it like I showed you, you either scan the cells, grab a bunch of cells that you want to be using, scan them, and then then assign them. So you'll see that on the battery you have the required cells, 16 cells. That's helpful if you want to grab them manually. Okay, I need 16 cells for this. You select them, assign them, save the pack, and if you refresh the page, it will tell you that you have 16 cells assigned. Still have to solve the capacity and type that in. But yeah, that's it, guys. That's with the update. Like I said, if you have questions, don't hesitate to contact me on Deep Cycle Power and check out the latest products that we added. I also made a presentation page where you can learn more about this project. I will leave the link in the description of this video as well. So this is a very detailed video where I go through the entire process of building a pack, and I talk about the reason for building the Megacell Charger. So if you're new to this, if you're new to building batteries, for sure go and check this out. You'll see that we have different packages right here, and a lot of information about the pros and cons of using the advanced Megacell Charger versus Opus or Litho Color, which are less expensive devices but also gives you less options when it comes to testing your cells and visualizing the data that you just gathered. So thank you very much, guys, for following this project. So I will see you on the next video. All the best.